Hey guys. Okay, so you guys are going to follow along with these notes that I'm taking. There's only a couple practice problems, and then you'll get a homework page, and you guys can work with a partner, so one other person. If you can whisper and work quietly together, that's fine. So graphing proportional relationships and unit rates. That's kind of what we're talking about today. So a unit rate, how much something changes when you move up one. Unit is singular, so it stands for one. So then per, when you see the word per, you've seen it before, stands for one of something and multiplying. Per, that means there's usually going to be a variable next to it like x. Unit rate is calculated using the slope formula. So the slope formula, y equals mx plus b, or in this case, since we're talking about unit rate, y equals mx. Remember, table, x is always first, y is always second. In your calculator, list 1, list 2. To graph, remember x and y, you go to the side to side first, your horizontal change, then you go up and down second, so your vertical change. So down here at the bottom, graph the data into the table. Draw a line connecting to the dots when you are finished. So time in years is our x value, height is our y value. So we're just going to graph these points like you would any ordered pair. So time in years, we've got 2, and the height was 6. When the time in years was 4, the height was 12. And when the year was 5, the height was 15. Oh, not so straight. But you're going to draw a line through those. When they talk about unit rate, in this case, it would be the height over your years. So we'd want to see what the height was when they're 1 year old. That's kind of what unit rate means, something over 1. For 1 unit, what's the rate? Flip over to the back. The next example, calculate the unit rate. So in this case, they gave us the graph. We want to figure out what the unit rate is. So we got to find some pretty points. I'm going to say that one's a good point. 800, let's see, 1200 over 60. We always want to use the smallest one because you're going to have to reduce it anyway. So we might as well look at the closest one we've got, which is our change in y cost over feet. So we've got our cost was 420 feet. This is prices for a cedar fence. So 200, nope, 400 over 20. So then we want to reduce this down to see what the unit rate is for 1. If it's $400 for 20 feet, we want to see what is it for 1 foot. Since these are pretty nice numbers, we can just reduce this down. So that would be 20 over 1, or you could divide that in your calculator. 20 over 1, so $20 for 1 feet. That's what that means. The unit rate is $20 per 1 foot. Example, we want to calculate the unit rate from a table. You're doing the same thing here. You just want to find your change in y over your change in x. When the table is kind of sideways like this, it's easy to get confused, but just remember your top row is your x value, the bottom row is your y's. So the difference between 76.5 minus 42.5, 34. The difference, 9 minus 5 is 4. 15 minus 9 is 6. 127.5 minus 76.5 is 112.5. I realize these aren't the same, so we can just look at one set. We still want to look at the change in y over the change in x. In this case, we're talking about dollars over tickets. So I'm going to use these two numbers first because there's not a decimal and I like it prettier. So $34 per 4 tickets. So we want to see what is the cost of 1 ticket. So in your calculator, you can just divide 34 by 4. It'll give you 8.5. So basically what this is saying is it's going to cost $8.50 per 1 ticket. And then the last example, Amy earns $5 per hour. So dollars over hours, she earns 5 per 1 hour. So instead we found our unit rate, they already kind of gave it to us. I'm just putting it in how you would normally want to see it, and then we're going to graph it. So this is our dollars, this is our hours. So in 1 hour, she earned $5. That's going to be your point. So that would mean in 2 hours, she earned $10. 3 hours, 15, and so forth. So one thing we haven't really talked about just yet, because we've just graphed them, all of these relationships are proportional. We're looking at unit rate, and these are all proportional graphs. If you are given a graph, you can know it's proportional if it goes through the origin. And these, we don't have the 4 quadrants, we just have the 1, but still we have 0. This is 0, 0. So when your slope line goes through the origin, or 0, 0, then it's proportional. Same thing here. Goes through the origin, so it's proportional. Okay, you have this homework page, or practice page, that's what it's called. These are kind of tricky. All you're doing is you're matching these to go with these over here, and you can have more than one match. Like you can match these graphs with these more than once. Just remember when you're looking through these, Emma takes 5 minutes to run 30 laps. So it's going to take her 30 laps in 5 minutes. So you want to see how many laps can she run in 1 minute. See what I mean? So you're not going to find a graph. You may with 30 and 5, but you're going to have to reduce these down. Same thing here. The runners cross the finish line at a rate of 5 per minute. That one's already reduced down, 5 per minute. Daniel loves books and reads 14 pages in 6 minutes. So 14 over 6. So how many pages in 1 minute? So you're going to have to kind of set them up like this so you can find a graph that'll match. Once you reduce it down, it'll be easier to find these graphs. The other thing that was weird, D on this graph, it's going up by 3s. So 3, 6, 9, 12. So I think that's the only other thing that's weird. You've got this page, and then this is the back of that page. Vocabulary activity, journal. Just do your best to explain this unit rate. A good example, real world example, at the grocery store, gas station, stuff like that. Yep. Vocabulary activity, matching graph 1, graph 2, graph 3. Like I said, you can work with a partner. If you can work with the partner, if you're going to be loud and obnoxious, then no, you can't. Okay, this is it for today. Have a good day.